We're going to review really quickly the procedure that we have to go through when we are asked to prove continuity of a function. Usually, if we're looking at a graph, it's pretty easy to see whether or not a function is continuous, but if we're being asked to prove whether or not a function is continuous, there's a specific three-step process that we need to go through. So let's review what the three steps are. So in order for me to prove that a function is continuous at a given point, we need to prove that three things are true about that function: that it exists, it has a value at that point, that there is a value to the limit at that point, and that those two numbers, the function value and the limit value, are the same. Three pretty basic steps, but what's important to remember is you have to use proper notation on this. So when we talk about proper notation, that means limit notation. It means naming functions correctly and keeping track of using mathematical language in terms of proving this. If in the question you are asked, is the function continuous, then you need to determine if there's points that you need to check at. And if not, you can say it's a polynomial function or whatever, but you may have to determine for yourself at what points you need to check for continuity. So let's take a look at an example for this. Here's our first function. We have a piecewise function, and this is generally where we have to do most of the work, is on a piecewise function to determine if it's continuous. Now, the first thing I have to think about this is, do I even need to concern myself with continuity? Both of these functions are continuous functions. But what I'm concerned about is the fact that at x equals 3, this function transitions from being the upper function to taking on the value of the lower function. So when x is less than 3, the function value is determined by the upper function. If x is greater than or equal to 3, it's determined by the value of the lower function. And our question is, does that mean that function is continuous? So remember that the first thing that I need to check is I need to determine if that point f of 3 exists. Again, when we talk about using correct mathematical terminology, I'm not just going to say yes, or I'm not just going to state a value. I'm going to do the work in such a way that it shows that I know which piece of this function we're using. So I'm going to find f of 3. I see that I'm going to use the lower function because it has the less than or greater than or equal sign. So I'm going to write down here that's negative 2 times 3 plus 6. Which is negative 6 plus 6, which is equal to 0. So I have a value for f of 3 of 0, and so it meets the first condition. Now the second condition is, does the limit as x approaches 3 of f of x exist? Again, this is one of those places where you've got to remember, how do I prove the existence of a limit? I don't just say it's equal to this. We need to do a left-hand limit. So I'm going to figure out the limit as x approaches 3 from the right-hand side. I'm going to do a left-hand limit. I'm going to do as x approaches from the left-hand side. And I'm going to see whether those are the same. Again, like I did above, I'm going to determine which piece of the function do I need to use. So when x is approaching 3 from numbers above it, that again is this lower function. That is x greater than or equal to 3. So I'm going to evaluate negative 2 times 3 plus 6. And by writing out that equation, I'm demonstrating that I know which piece of the equation I need to use for my right-hand limit. My left-hand limit, then, I'm going to use the upper function. So I'm going to evaluate negative 3 over 2 plus 3 over 2. And again, this is showing I know which piece of that function I need to do that is also equal to 0. Since those two numbers are the same, I know, I'm going to write therefore, the limit as x tends to 3 of f of x equals 0. So there I have my limit exists. That's part 2. What does part 3 say? It says, is f of 3 equal to the limit as x tends to 3 of f of x? And in this case, I can see in part 1, I determined that that was equal to 0. In part 2, I determined that that was equal to 0. They are the same. I'm going to check it off. Again, I'm not done because I still need to write out, yes, f of x is continuous. And I'm going to write my answer out depending on how the question asked. This question just asked, is it continuous? I'm going to write f of x is continuous everywhere. Because it didn't specify that I needed to look at 3, but I can tell that 3 is the only place that I need to look at. So there's an example of how the 3-step process looks up when I'm doing a problem that is just checking for continuity, what it's going to look like when I do prove continuity of a function. Let's take a look at one that may not work out quite so well. So here's another equation, another piecewise function. I'm going to go through the same steps. So first one, again, I'm going to look at my equations. These two equations are both continuous equations. So the place that I need to be concerned about is the point at which the function transitions from the upper function to the lower function. So my first question is, what is the value of function -2? Does it have a value? I'm going to use my lower equation because that has the equal to bar in it. So I'm going to solve -2 times -2 minus 3, which is 4 minus 3, which equals 1. So the value of f of -2 is 1. Now I need to, my second step is determine, does the limit exist? So I need to find the limit as x tends to -2 from the left-hand side, and the limit as x tends to -2 from the right-hand side. Now, left-hand side means numbers that are less than -2. That's going to be my upper function. So I'm going to be finding the limit as x tends to -2 from the left-hand side of -x, which is -2, which equals 2. So that's my left-hand limit. My right-hand limit, I'm going to use the lower function again, so -2x minus 3 is equal to -2 times -2 minus 3, which is 4 minus 3, which equals 1. Here's our problem right here, right? I've got a left-hand limit of 2, I have a right-hand limit of 3. What does that mean for me? I will say the limit as x approaches 2 of f of x does not exist, because the left-hand, right-hand limits are not the same. So my conclusion for this then, again, if they're talking about continuity, I need to answer the question about continuity, and I would be able to say that f of x is not continuous at that one point where x equals -2. So there's an example of one that falls apart in the process, in this case because the limit fails to exist. So here's our last one right here. What I'd like you guys to do is to pause this video for just a second, work through this process, and see if you can determine whether or not this function is continuous. Okay, I'm going to assume that you paused it and you worked it out, and let's see what happened. Again, two continuous functions, so I'm just going to be concerned about the point of transition. So I'm going to find out what is the value of the function at -1. Well, I have x not equal to -1, x equal to -1. That's pretty straightforward, that f of -1 is 4. Okay, next piece is the limit. So I want to figure out the limit as x approaches -1 from the left-hand side, and the limit as x approaches -1 from the right-hand side. So in each of these cases, it's the same function. It's this guy right here. So I'm going to do -2x equals -2 times -1, which is 2. And from the right-hand side, still -2x. So -2 times -1 equals 2. Therefore, since they are the same, the limit as x tends to -1 of f of x is going to be equal to 2. So we've got a limit. We have a function value. What does the last piece say? Does f of -1 equal the limit as x tends to -1 of f of x? That's the last thing I have to prove. And in this case, my value of the function was 4. My value of the limit is 2. They are not the same. So this example actually falls apart in that last step of showing that the limit and the value of the function are the same. And so my conclusion on this one is that no, f of x is not continuous at that last point that we saw, or the point that we checked at x equals -1. Now, because I've shown all the work here, I don't really need to go into any more detail. You can always, in a conclusion, it's always a good idea to say, because the limit and the value of the function are not equal to each other. But as long as I have gone through and shown really clearly the steps of evaluating and the steps of working through the limit, I don't kind of need to reiterate the conclusion, but all this work needs to show. So there's our review on how to determine whether or not a function is continuous at a given point.